There are a couple more terms we need to learn, and one of these terms is a monomial. A monomial. So, a polynomial can be classified by the number of terms. A monomial means that there is just one term in the polynomial. For example, if I have just negative 2x, that's a monomial. If I have just 8, that's a monomial. Or 23x squared, again, that's a monomial. Then we have a binomial. Well, a binomial has two terms. Notice mono means one, binomial, bi means two. So if I have a binomial, then that's 3x plus 2. That has two terms, that's a binomial. What about 14x squared minus 10? That is also a binomial. Next is a trinomial. Tri means 3. So a trinomial has three terms like negative x squared plus 3x plus 9. That's a trinomial. Or 2x to the 5th minus 4x squared plus 2x. That is also a trinomial because it has 1, 2, 3 terms. And then anything that has 4 or more terms is just called a polynomial. Just a polynomial if it has 4 or more terms. So if I have something like 14x cubed minus x squared minus 4x plus 6, that has 1, 2, 3, 4 terms. 4 terms means a polynomial. Now notice all of these names, all of these classifications only occur once the polynomial is in simplest form. So that means if there are any like terms we need to combine, you combine them first. Once you do that, then you can classify it. So last thing we're going to do on these 11.1 notes is take these 4 examples, put them in standard form, classify them, and talk about the degree of the polynomial. So here's the first one. We need standard form. Remember, standard form, we have to look at the degree of each term. So the degree of 8 is just 0, degree of negative 12x squared is 2, and degree of negative 10x is 1. So for standard form, we have to put them in decreasing order of degree. So put the highest degree first. That's going to be negative 12x squared. Then we put the negative 10x because it has the next highest degree, and then we put the 8. So now it's in standard form. Well, now that it's in standard form and in simplest form, we can classify it. It has 1, 2, 3 terms, and 3 terms means a trinomial. So this is a trinomial. Lastly, we want the degree of the polynomial. So the degree, or I said polynomial, but we can say specifically it is a trinomial. The degree is going to be 2 because that's the degree of the highest term. So this is a degree 2 trinomial. Let's look at number 2. We need it in standard form. So 9 has a degree of 0, negative 4x squared y. Well, x squared has 2. Y has a 1, so we add them, and that is degree 3. And then x squared is degree 2. So now we need to put them in order of decreasing degree. Highest degree goes first, negative 4x squared y. Then the next highest degree, so that's going to be plus 8x squared. Then our constant term plus 9. Well, again, this has 1, 2, 3 terms, so it's a trinomial. And we need the degree. So for the degree, if it's in standard form, we can look at the degree of the leading term. Well, that degree we said is 3 because x squared plus y to the first, that 2 plus 1 is 3. Go ahead and try numbers 3 and 4 on your own. Pause the video and then start it once you finish. All right, let's check these together. 5y has a degree of 1. Negative 7xy squared has a degree of 3 because the x we know has a 1. So let's put them in standard form. Highest degree goes first. That's negative 7xy squared. Then that positive 5y comes last. Well, this has 2 terms. Therefore, it is a binomial. We need the degree of this binomial. The degree is going to be 3 because that is the degree of the highest term. And last one, this 4y squared has degree 2, 6x squared has degree 2, Then we have x squared y squared degree 4 and xy squared degree 3. So we need to put the highest degree first, so 3x squared y squared first. Then we're going to put the next highest degree, negative 8xy squared. Well, now these have the same degree. We have a y squared, we have an x squared. So we talked about if they have the same degree, then we go to alphabetical order. That means the x squared will come first, and then last the y squared. Well, we have 1, 2, 3, 4 terms. That makes it a polynomial. And then the degree of this polynomial, we go to that first term when it's in standard form, and that 2 plus 2 gives us degree 4. Go ahead and head over to the 11.2 notes. All right, 11.2 is adding and subtracting polynomials. So the first thing we're going to do for this front page is look at algebra tiles. Algebra tiles are used to model mathematical concepts. So we have positive algebra tiles and we have negatives. If we see this big square, that is x squared. That stands for x squared. Then this rectangle stands for x, and this little one stands for 1. And notice these are all positive. Positive x squared, positive x, and 1. Then we can also have the big box stand for negative x squared, and if that's the case, then we'll just draw a negative sign in the box. Then the rectangle can be negative x, and the little box can be negative 1. So we just use these to model adding and subtracting of polynomials sometimes because it just gives us a visual representation of what's happening. So let's try it with an example. We're going to add the polynomials using algebra tiles. To do that, we have 3 steps. We're first going to model each polynomial. Then we're going to identify and remove 0 pairs. 0 pairs are things that cancel. They cancel each other out. And then we're going to write the new polynomial. So here's our first example. We're going to model each polynomial with algebra tiles. So 3x minus 3. We want to draw 3 of the positive x's. So if it's positive, I just put a plus sign in it. We want 3 positive x's, that's the tall rectangle, and then we need 3 negative of the little boxes. So I'm just going to draw 3 little boxes with the negative sign. So we've modeled 3x minus 3 with algebra tiles. Now we're going to model negative x plus 6. Well, negative x, I just need 1 negative tall rectangle. But now I need 6 of the positive little boxes. So we need 6 of them with plus signs. And it is important that you put your plus and your minus signs. Excuse me. All right, now that we have drawn them, what we're going to do is add them together. We're going to add these polynomials. And to do that, first we need to identify and remove 0 pairs. So 0 pairs are things that cancel. If I have 1 plus and 1 minus of something, they cancel out. So let's look at our x's. I see 1 negative over here. So if I pair that with 1 positive x, they're going to cancel out. So for my 0 pairs, I'm going to put 1 positive and 1 negative x together because a positive and a negative are going to cancel. Well, now we need to look at what our leftovers are. If we cancel the positive and the negative x, what's left over with the tall rectangles? We have 2 positives left. 2 positives. Well, now let's look at the little ones. I see 3 little negative boxes, and I see 6 positive little boxes. So if I take 3 negatives and 3 positives, those are 0 pairs. Those are going to cancel. So I'm going to take a negative and a positive, and I'll just cross them out as I take them. We also used all these already. I took a negative and a positive. Now I'm going to take another negative and positive. And one more pair of negative and positive. Because now all the negatives are gone, and then we have 3 positives left over. Okay? So we modeled them. We took the 0 pairs. That just means what's going to cancel? A positive and a negative cancel, and we were left with 2 of the positives. Positive and negative cancel, and we were left with 3 of the positives. So in our 0 pairs, plus and minus are going to cancel. All of these cancel because we have pairs of pluses and minuses. So what's left over? We have left over 2 positive of the x's, and that gives us 2x. We also have left over 3 of the little positive boxes, and that gives us positive 3. So when we combine these, when we add these polynomials, what we're left with is the polynomial 2x plus 3. So our solution to the addition of these polynomials, ultimately this is what we did. We added 3x minus 3 to negative x plus 6. If we add those together, we get 2x plus 3. And on the back of the page, we'll talk about how to do it without algebra tiles, okay? So that's how we use algebra tiles. Let's do one more example with algebra tiles at the bottom. Add the polynomials using algebra tiles. So we need to model each of them. First, let's model 2x squared plus 3x plus 6. Well, 2x squared, that's a positive 2x squared, so I'm going to draw 2 of the positive boxes. Then I need a positive 3x, so that's going to be 3 of the positive rectangles. And I need plus 6, so that's going to be 6 of the positive little boxes. So we have just modeled 2x squared plus 3x plus 6 with algebra tiles. Now let's take 3x squared minus 6x minus 4 and model it with algebra tiles. Well, 3x squared, we're going to need 3 of the positive x's. And then negative 6x, we need 6 of the negative rectangles. 2, 3, 4, 5, 6. And then we need 4 of the negative little boxes. Okay, and this is that one, 3x squared minus 6x minus 4. Well, what we do next is talk about 0 pairs. Remove the 0 pairs. I don't see any 0 pairs with the x squareds because they are all positive. So I'm going to go ahead and add those up. I have 3 positives here, 2 positives there, so that gives me 5x squared. Let's talk about the x's. I see a positive and a negative here, so I'm going to cancel out that pair. That's a 0 pair. I see another positive and negative 0 pair, and one more positive and negative 0 pair of the x's. So now what's left over? 3 negative x's, so negative 3x. Lastly, let's look at our little boxes. I see a positive and a negative, so there's a 0 pair. Positive and a negative, 0 pair. Positive and negative, positive and negative. So what are we left with? 2 positives, so that's plus 2. So this is how we add with algebra tiles. And this is something you could see on the EOC, and that's one reason we do it. Another reason, it can just be helpful for us to visualize.